So the next series of questions are kind of vocabulary. A teacher out at Foothill High was doing some multiple choice questions that were similar to this, and I was kind of inspired by what she was doing, and I said I should use a couple multiple choice questions. So I came up with these four questions. The first one says, which exponential function has an initial value of 8? An initial value of 8. In other words, if you're starting out and you're looking at the beginning spot of some exponential function, and let's actually look at kind of some generic well, I don't want this highlighter pen. Some generic exponential function. So if I look at y equals 3 times 2 to the x power, for example, when x is 0, right, when this number x is 0, we know that becomes 2 to the 0 power becomes the number 1, and 1 times 3 is 3. So when x is 0, you can verify this with your calculator. You plug in the 0 up there, and you're going to get an output value of 3. When x is 1, we end up doubling the 3, and we go up to 4, 5, we go up to the number 6. And then when x is 2, we double it again, and we're way up at 12. So, exponential functions do this thing, right? They have the initial value, right? What happens when x is 0, and they also have the multipliers. In this case, we're multiplying by 2 each time. And I know this is a little confusing because earlier on when we were talking about sequences, we always said the first term. The first term was what occurred when x was 1. But I'm saying here the initial value, if this is just starting out when x is 0, you're going to get a value of 3 out of that function. So if I come back over here and I think about that, I'm looking for an initial value of 8. Well, first of all, this is not an exponential function. That's a line. The remaining 3 are exponential functions. B and C have multipliers of 8. So every single time they're multiplying by an additional 8. Remember what exponentiation does. It allows you to show repeated multiplication. So those ones just keep multiplying by another value of 8 as they move forward. The last one, D, does have an initial value of 8. It starts at 8, and its multiplier is 3. So every single time it's multiplying by 3, but it has an initial value of 8. So D is the correct answer for 2. For 3, it says, which exponential function has a multiplier of 1/2? Well, it's not C, that's linear, and it's not D, that's linear also, right? This one has a y-intercept of 3. D has a y-intercept, you could put it here, of 0, and both of those have slopes of 1/2, so which means up 1 over 2. No, up 1 over 2, yeah, so it's got each time you're adding 1/2 as you move forward there. The one that's got a multiplier of 1/2 is choice A. This one has an initial value of 1/2, and its multiplier is 32. This one has an initial value of 32, and its multiplier is 1/2. So if I was to look at that sequence, it would start out with 32, and then go to 16, and then go to 8, and then go to 4, etc. So those are those values that I would expect if I plugged in 0, 1, 2, and 3. Number 4 says, oops, sorry about that. Number 4 says, what values of x make this equation true? So I've come over to a separate space to kind of look at this problem independent of the multiple choice. And I just want to talk about what absolute value means. So think about this. This thing inside of the absolute value, this 4x minus 2, that thing can be one of two things. It is either negative 26 or it's positive 26. And just think about the thinking of this, right? The absolute value of negative 26 is 26, and the absolute value of 26 is 26. So what I'm saying is this right here, this 4x minus 2 is either negative 26 or it's positive 26. So that's basically the key insight to how do I deal with absolute value. We basically get rid of the absolute value, but when we do it, we get two separate equations that are joined, in the case of equality, they're joined by or. So here's our two equations. We say that this thing inside, the 4x minus 2, is either negative 26, right? Or this thing inside, the 4x minus 2, is positive 26. So there's two clear, distinct situations, right? Either the thing inside, is a negative 26, or the thing inside is a positive 26. In which case, it would force this to be true. The absolute value would be positive 26. So we solve these independently, and it's the same two steps, but notice you get different answers. For the first case, if I add the 2 to each side, I get that 4x is equal to negative 24. And if I divide both sides of that by 4, I get x would be a negative 6. On the other side, if I add 2 to both sides again, I'm going to get that 4x is the 28, number is 28, and if I divide both sides by 4, it would produce a value of 7. So if x is 7, I get 26, and if x is negative 6, I get 26 from this function. And verify it. 4 times negative 6 is 24, right? If I was to put in the negative 6, this would be a negative 24, and if I subtract 2, it makes a negative 26, and when I take the absolute value of it, I get 26. It's perfect. It's beautiful. And in the other case, if I plug in the 7, 4 times a positive 7 is 28, and 28 minus 2 gives me positive 26, and the absolute value of that is also 26. So two very distinct solutions. X is either negative 6 or x is 7. And I'll tell you, the thing that I think students do every year is they look at this and like, oh, this is easy. Just ignore the absolute value, get an answer, and make the other one the opposite of it. That almost never works, right? So please think about it. Think about the fact that there are two things that are possible. Either the thing inside is a negative 26 or the thing inside is a positive 26, and just deal with that. So, and when we come back and look at our multiple choices, we said it was either negative 6 or positive 7, and you can see the one where that's true is choice D, right? Negative 6 and positive 7. So D is our solution. And then the final one here is says which inequality is represented on the number line below. The thing that I'm noticing is this is clearly an open boundary point, so that means that it's either going to be greater than or less than, right? If that was a closed boundary point, I put a dot over here. If it was a closed boundary point, we'd either have greater than or equal to or less than or equal to. But this is an open boundary point, so we're using one of these two symbols. And you look at it, x's are all those things that are this side of it. They're less than that. So we want x's are less than 5, and the only choice where that is we do have less than or equal to. That would be fine if it was a solid dot, but for our question, we want choice D. X values are less than 5.